In this lecture 4, we are going to deal with octal number system, octal to decimal conversion, decimal to octal conversion, octal to binary conversion, binary to octal conversion, and also if possible binary addition and binary subtraction. Now, in the earlier lectures, we have seen how we can convert a binary number to decimal, decimal to binary. Decimal is a number we all are familiar with, but when computers came into use, we had to switch over from decimal to binary, and we have seen all those conversions in the earlier lectures, and also we saw how hexadecimal number system becomes more handy when it comes to bigger numbers. Now, in today's lecture, we are going to see another new number system known as the octal number system. In this octal number system, what we are going to see is it has 8 digits starting from 0. It has digits like 0, 1, 2, 3, 4, 5, 6 and 7. So, it has a base 8, but you can notice here that the numbers 8 and 9 are not used in octal number system, and octal number system, as I said earlier, has a base 8, but binary number system has a base 2, and this 8 can be written as 2 power 3, which means any octal number or octal digit can be represented as a group of 3-bit binary sequence or 3-bit binary number. Now, this is what is being shown in the table that follows, and you can see that 0, which is octal number, the 0 in decimal number can be represented as 0 0 0 when it comes to binary number. So, every octal number can be represented by 3 digits when it comes to the binary number. 1 becomes 0 0 1. Same way 2 can be represented as 0 1 0. 3 becomes 0 1 1. 4 is 1 0 0. 5 is 1 0 1. 6 is 1 1 0. 7 is 1 1 1. So, you can see that this is how we represent all these numbers, and this is also useful when it comes to conversion of octal to binary and so on, which we will be doing in the course of the lectures. And now, we will first see how a octal number system can be converted to a decimal number. As we all know, decimal number is something we are familiar with. So, first we will start with the conversion of octal to decimal. Now, here the only difference is the use of the weights. See, in the hexadecimal number system, we saw that we used weights like 16 power 0, 16 power 1, 16 power 2 and so on. In binary number, we used weights such as 2 power 0, 2 power 1, 2 power 2 and so on. Here, when it comes to the integer part, we will have to use weights like 8 power 0, 8 power 1, 8 power 2 etc. When it comes to the fractional part, that is when it comes to the right hand side of the decimal point or the octal point, we will have to use weights like 8 power minus 1, 8 power minus 2 etc. And as I said earlier, like we have a decimal point and hexadecimal point, binary point. Here we have also another point known as the octal point. So, this also should be borne in mind, and now we will see how we can convert a number to a decimal number. So, we are taking an example of 75, which is an octal number. So, when we convert this to the decimal equivalent, you can see what we will have to do is we have to take 5 and multiply by its weight, which is 8 power 0. The next number 7 is multiplied by its weight 8 power 1. So, what we will get is 5 into 8 power 0. Any number when it is raised to power 0, we know it is 1. So, we get 5 into 1, and 8 to the power 1 is 8 only. We know 7 into 8 gives us 56 and 5 into 1 is 5. So, you can see the 56 plus 5 is what we get, and the answer will be 61. So, 75 which is an octal number gets converted to 61 when it is converted to the decimal number system. Now, you can see another example here. Now, we will try to do it. So, if I take 62, it is a octal number. So, what should I do now? I should multiply 2 by its weight. What is the weight of 2? It is 8 power 0. And what is the next number I have? 6. And what is the weight of 6? So, next to 8 power 0 I should have 8 power 1. So, we know that 8 power 0 is nothing but 1. So, it is 2 into 1. Here it is 6 into 8. So, what I will be getting will be 48 plus 2, and this answer will be 50, which is the equivalent in decimal number system. So, the 62 which is an octal number is getting converted to 50 when it comes to the decimal number. So, this is what you should understand. The next number that we are going to see is 45.6. So, here I am taking a number to the right of the octal point. So, here again first I will write the number and then we will convert it. So, 45.6 is the octal number we have. So, now what I should do is I should take this 45, that is the integer part, and first I should convert that. So, 5, what is the weight of 5 when it is in the octal system? It is 8 power 0. And what is the weight of this 4? It is 8 power 1. So, this becomes 5 into 1 and this is 4 into 8, which will give me 5, and here I will get 32. So, the answer will be 37. This is for the integer part. When it comes to the fractional part, you know the weight I will have to use is, for 6 I will have to use the weight 8 power minus 1. Suppose there is one more digit after this. For example, if I take 6 2 here, if I taken a 2, one more 2 like this, no 2 here, what I should do next? I should take that as 2 into 8 power minus 2. Since here we have used only one number, which is only 6, I need not use this number. So, I am not going to use this. So, I am stopping with 6 into 8 power minus 1, which is nothing but, see here, 6 by 8. What is 6 by 8? It is 3 by 4. And what does 3 by 4 give us? 0.75. So, what will be the answer for this 45.6? It will be 37.75 when it is converted to the decimal number. So, this is what you should remember. Any digit that comes to the left of the octal point should be multiplied with its weight 8 power 0, 8 power 1, 8 power 2 and so on, starting from the least significant digit. When it comes to the right of the octal point, we should take the weights as 8 power minus 1, 8 power minus 2 and so on. So, this is what is important, and next we will see how we can convert a decimal number to an octal number. So, this is similar to what we did earlier. In the binary number system, what we did was, we took the decimal number, we divided the number repeatedly with the number 2 and we took the remainders, taking it from top to bottom. Same way in the exact decimal number system, what did we do? We took the decimal number and divided the number repeatedly by 16, and again we took the remainders and we took it from top to bottom in the hexadecimal form. So, the same way here what we should do is, we should take the decimal number. To convert the decimal number to octal number, we have to divide it repeatedly by the number 8, and when we do that, we will get remainders. That remainders we will have to take from top to bottom, and that number again we should take it in the octal number form. So, this is what we are going to see now. Let us take one example, the number 68. The 68 is now in the decimal number form, and let us see what we will get. See, what we have done here is, the 68 is divided by 8. So, in 68 the 8 will go how many times? 8 times it goes. So, you get 64 and the remainder is 4. Now, in 1 8 will not go. So, you get a 0, the 1 comes here. So, the 1 comes as a remainder. Now, we have to take from top to bottom, which means the most significant bit to the least significant bit. That is how we should write the answer, because it is in the octal form now. So, 68, which is a decimal number, gets converted to 104 when it comes to the octal number system. So, 68, which is a decimal number, is 104 in the octal number system. So, this you will have to remember. The next important thing is, let us take one more example, like we will take 0.5. Now, so far we have seen only the integer part. Now, we will see what will happen when we take a fractional part, fractional number 0.5. How to convert 0.5, which is a decimal number, to an octal number? What we will have to do is, we will have to multiply the decimal number 0.5 with 8 and take the carries. 0.5, 5 when you multiply with 8, you will get 4 and a 0. So, the carry is 4. So, that 4 can be written as 0.4, it should not be written as 4, it should be written as 0.4. So, 0.5, a decimal number, gets converted to 0.4 when it comes to the octal number. If you want, you can take some other example also. Say for example, we have number like 625 or 6. How to convert this to a octal number? This may be a binary, this may be a decimal number. So, what we can do is, we can multiply 0.626, see we can take 626 and we can multiply it, and what we can do is, when we multiply, what do we get? We get 8 here, 4, 16 will go in that, we will get 2 and again 48, you will get 50. So, we are getting a carry 5. Now, we have the number 008, which can be again multiplied by 8, and what you will be getting will be 64, 0 and 0 as a carry. Again 0.64 can be multiplied by 8, like this you can go on. What you will be getting will be 32 carry 3, 48 will go 51 and a 0. Again 0.512, if you multiply by 8, you will get 16 carry 1 and 9, and you can see you will get a carry 4. So, now I can write this answer as, I can stop with this, I can go on like that, but it is not necessary. We can write the answer as you should start now from here 5004, and this will be the octal conversion of 0.626, which is a decimal number. See what I have done, I have taken 0.626, I have multiplied by 8 and I got 8 carry 4, 16, 20 carry 2, again 48, 50. So, I have got a carry 5. That 0.008 alone I am multiplying by 8 to get 0.064. Again that 0.064 is multiplied by 8 and I get 0.512. 0.512 when I multiply I am getting a carry 4. So, what I have done is, I have just taken the carries alone and I have written 0.5004, which is a conversion of 0.626 in the decimal number system to the octal number system, which becomes 0.5004. So, this is what you should bear in mind, you should not keep doing it again and again, you can continue, but that is of no use. So, this is what you should remember in mind. If you get any number, if it is a fractional part, you have to keep multiplying and take the carries and represent it in the octal form. So, let us take another example of the same conversion from decimal to octal. So, I have taken a number 109. So, this 109, if I want to convert it to its octal equivalent, what I should do is, I should divide by 8, because it is only an integer part, there is no fractional part in this number. So, what I will be getting is 1, and in 29, 8 will go 3 times, is not it. So, we are getting 10 1 times, in 29 it goes 3 times and the remainder will be 5. Now, This 13, if you further divide by 8, what you will be getting will be 1, and you will get again remainder as 5. 1 if you divide by 8, you will get 0, and the remainder will be 1, and we should take the number always from the most significant bit to the least significant bit. So, the answer for this 109, which is in the decimal form, will be equal to 155 in the octal number system. So, this is the point you should remember. The same can be obtained with another number. So, 98.625. So, here I have taken both the integer part as well as the fractional part. Now, let us try to convert this. Here when we convert, what we should do first is take the integer part and start dividing by 8. What you will be getting will be 12 and 2. Again the 12 can be divided by 8 to get 1 and 4. Again if you divide this, you will get 0 and 1. So, the integer part will give you 142. Now, coming to the decimal fractional part. Fractional part, what we should do? We should take that 625 and multiply by 8. What we will be getting will be 40, 16, 20 and 5. So, you can see that we get a carry of 5. So, what is the answer for this? The answer for 98.625, which is taken in the decimal form, is 142.5 in the octal number system. So, what we have taken as 98.625 in the decimal number system gets converted to 142.5 in the octal number system. So, next we will see how we can an octal number to a binary number. So, as I said earlier, the base of octal number is 8, which is nothing but 2 power 3, and we also saw a table earlier in which every octal number is represented by a 3-bit binary number. So, if we take a number 1 in the in the octal number system, in the binary number system, the same can be represented as not 1, but it should be 0 0 1. The same way 2, suppose we take 2 in the octal number system, how can it be represented in the binary number system? It becomes 0 1 0. Same way 3 will become 0 1 1, and 4 can be written as 1 0 0, 5 becomes 1 0 1, 6 becomes 1 1 0, and 7 is 1 1 1. So, this you should remember, and this is what already I have shown in the table earlier. So, just we have recollected what I have shown earlier. So, now this is what we should do. Every digit which is in the octal form should be written in 3-bit binary form. It should not be 2-bit, it should be only 3-bit, and it should not be 4-bit also. If it is a 4-bit, then it becomes a hexadecimal. So, 3 bits only we should use. So, this is what you should remember. So, I have shown some examples here. You can see I have taken a number 27. The 27 can be written as, see, the 2 is written as 0 1 0, as I said earlier, and 7 is written as 1 1 1, and in decimal it will be 2 3. We are not worried about decimal now. Decimal conversion, how do you get? You will have to convert the octal, you have to multiply every term by the weights of that number, okay? Only then you get the decimal equivalent. So, that is different. We are only now going to see how octal and binary, how octal can be obtained in the binary form. So, 135, 1 cannot be written as 1, I told you, it should be written as 0 0 1. 3 cannot be written as 1 1, but it should be written as 0 1 1. Same way 5 becomes 1 0 5. Same way 45.5, you see 4 is written as 1 0 0, 5 is written as 1 0 1, and this 5 is again written as 1 0 1. So, this you should remember in mind. So, this is how we convert octal to binary form. And now, what we will do is we will convert binary to octal. Now, here we have to be very careful. Again, when we convert a binary to an octal number, as I said earlier, when we converted hexa to a binary to hexa, what did we do? We grouped the binary numbers as 4 bits, because in hexa we always need 4 bits. When it comes to octal, we need 3 bits. So, if anything is lesser than 3 bit, what we can do is we can add zeros, like we did in the conversion of octal to hexadecimal. Here again, from the octal point, we should always go towards the left when it comes to the integer part, and we should move towards the right when it comes to the fractional part. So, this points we should bear in mind, and we should add zeros accordingly. So, if you take a number, see, if I take a number 10101, what happens is this 101 is already a 3 bit binary number. So, I need not do anything with it, but when it comes to this 10, it is not a 3 bit binary number. So, what I can do is I can add a 0 to the front of it as it is shown here. See, so it becomes a 3 bit binary number, this is also a 3 bit binary number. So, it is okay now. So, the number becomes, what is this 010? It is 2, and what is 101? It is 5. So, we can write the answer for this as 25. So, you can see that 10101 becomes 25. So, the binary number which is taken as 10101 gets converted to an octal number 25. So, this is what we should remember, and the next one we are going to see is how we can write different numbers. So, you can see 110.101, it is a binary number, and what have we done? This thing is written as it is in the 3 bit number, because both are 3 bits. So, no problem, this also is 110, this is also 101, this gives us 6 and this gives us 5. But look at the second number, is 10111.1. So, you can see on the right hand side of the octal point, you have only a single digit, that is 1. So, you can see that we have added a 0 to that 10 to make it into a 3 bit binary number, and what we will get for the 010 is 2, 111 is 7 and 100 is 4. So, the answer becomes 27.4. So, the number which we have taken in the binary form, that is 10111.1, is equivalent to 27.4 in the octal number system. So, this is one thing you will have to remember. Now, we will just take one number and try to convert it. That is for just to make you understand. So, if I take a number like this, see here I will rewrite the number here, and then we will go to it. Okay. So, 101,011, I can split it and write it as 11101. See, I have just left a small gap. You can see that both the groups have 3 bit numbers. So, no problem. What is this 101? It is 5, and what is the 011? It is 3. So, what is the equivalent of this in the octal number system? It becomes 53538. So, you can see that the binary number 101,011 can be written as 538, that is in the octal number system it becomes 53. So, this is what you should remember, and now we will see, we will take up another example. In this example, I have taken also 2 digits on the right hand side of the octal point. So, I will rewrite the number again. So, 1110.11. Okay, there is one more 1. All right. Now, this can be written as, again the left hand side can be written as 0, 1, 1 and 1, 1. So, you can see that this does not have 3 digits. So, I add a 0 here. Same way on the right hand side of the octal point also we do not have 3 digits. So, what should I do? I should add a 0 here. So, what does it give now? This gives me 3. What does this give? 6, and this gives also 6. So, what is the answer for this? The answer for this will be 36.6. So, you can see that this is the octal number I am getting for this binary number that I have shown here. So, this is how we convert a binary to octal number. So, what we have seen so far is how we can convert First we saw what is an octal number. Octal number is nothing but a number that has a base 8 and there are 8 digits in it starting from 0 and ending with 7. The numbers 8 and 9 does not come in octal number system. Then we saw that since it has a base 8, we can represent every octal number as a 3-bit binary number, and we also saw how we can convert an decimal number or octal number to first decimal number, then vice versa from decimal to octal number system, and we also saw how an octal number system can be converted to binary number system. Same way, if you have a number in binary number system, how you can convert it to octal number system. So, all this conversion things are very useful when it comes to the use in computers, because in computers whenever we want to write a program, we need ideas about all these conversions, especially the hexadecimal number system is a very useful tool when it comes to the understanding of microprocessor or any computer language. Now, not only that, we should also know a certain arithmetic, how this binary numbers can be used in addition. Binary number, as I said earlier, it is a very useful thing, because nowadays computer understands only the digital language, that is 0 and 1. So, we should also know how these numbers can be used in addition, subtraction, multiplication, division and all that. We are very familiar with decimal addition, decimal subtraction and so on. So, now in this topic what we are going to see is how we can use a binary number, or how we can add two binary numbers like we add two decimal numbers, because if we understand all that, we can also have an understanding of digital circuits like adder circuit, subtractor circuits and so on. So, that is a very important thing. So, it is very important to know the arithmetic part also. So, this is what we are going to deal with, and so far in this lecture we have dealt with one number system, that is the octal number system, and octal number system is also a very useful tool, and we also saw how this tool or how this number can be converted to all other systems, like from octal to decimal, octal to, if once you convert it to decimal, you can also convert it to hexadecimal very easily. Same way from octal to binary, from binary to octal, same way from binary we can also convert it to hexadecimal system and so on. So, and what is very important is, in all these things you should understand that we are going to see what you call the number systems, how it evolved also in the earlier lectures we have discussed. So, now that we have come to an end of all these number systems, I would like to give you certain assignments. The assignment that I would like to give you is, since we have done only the conversion of octal number system to different number systems, I will just give you some problems in which you have to convert a decimal number to an octal number, and from octal to decimal, and same way octal to binary and binary to octal. If you want, you can also convert the same number to hexadecimal with what you have understood from my earlier lecture. So, coming to the assignment part, I would like to say that you take up an assignment like this. First, you convert a decimal number 53 to octal number. Same way, you convert another decimal number 98.625. This is a decimal number 98.625, you convert it to an octal number. Same way, you convert an octal number 68 to decimal number, convert an octal number 68 to decimal number. Now, you take up another number, octal number 53.78 and you convert it to decimal number. Okay. Take another binary number 110.11 and convert it to an octal number 110.11. You convert that to an octal number. Same way, you take an octal number 79.825, 79.825 and convert it to a binary number 78.825 and convert it to an octal number. Okay. So, I think you would have noted down what I said. please try to do it, then you will have a clear understanding of how this conversions can be done. Thank you.